Yeah, thank you very much, Sylvia. So, hello everyone. I'm Kiran. I'm working as a zero test specialist here at Tata Elxsi. So today my presentation will be on subscription and notification support in OSM. So I have just a brief agenda here. So we will initially walk through over the problem statement, and we will see the design principles which we have followed to realize the support for subscription and notification. And then we will see how we have realized these design principles. And then we will have a high level overview on the workflow, and then the current support and the future roadmap for this feature. And then I'll be concluding my presentation. So, so is my screen visible? I think there is some lag. Yeah, I think now it should be visible. So my current slide is about problem statement. The feature is focusing upon the SOL file documentation. So as per the SOL, we have a set of northbound APIs through which entities can subscribe to network service lifecycle changes. So it can be either network service, or it can be VNFD, or it can be NSD. But for now, we will focus on the network service lifecycle. So the entities that want to get notified are called subscribers, and the ones who want to get notified are called notification receivers, and they expose something called as a notification endpoint. So that is the mechanism through which they receive the notification. So it is all through the REST. So there is something called as registration phase, and in the registration phase, and the subscribers use something called as filters. So through the use of filters, the subscribers will choose what are the events which they are interested in. So so that is how the registration phase is happening. And since subscribers can have their own REST API mechanism through which they receive the notification, they can have their own authentication mechanism for their APIs. So for now we have, they might not have any authentication. They might just accept any data which they are receiving. So no authentication, and basic authentication is supported as of now. And the another important thing is that we should have very little latency and make all the notifications near real time. And also the main important point is that we support deregistration of subscriptions. However, we do not support for modification of existing subscription. And hence the allowed HTTP verbs will be get, post, and delete, and invalid verb will be the put and patch. So this is the goal of the feature, and then we will see the design principles. So the core fundamental design goal is to have notifications of the network service lifecycles, or the network service, to be received as fast as possible. So for that we have certain design principles which we are following. So one among them is the data transformation at source. So the filters which I have talked in the previous slide, they are very complicated JSON objects, in the sense like the SOL API or the SOL request body. It is so that they can choose a wide variety of combinations for events. So we will see those things later, and hence the whatever incoming request body, it is going to be very complicated. So there is some need to transform the data. And the second one is the pre-check on the endpoint. So this endpoint is nothing but the notification endpoint. So when an event occurs, the NBI will be notifying to this endpoint. So we also make sure that this endpoint is valid and it is in proper order, so that we don't have any other additional latency in pipeline. And the other point is the redundant information. So we do not allow redundant subscribers in the system. If subscriber gives a filter and the notification endpoints and the authentication mechanisms are same, then we treat them as redundant subscribers. And this also leads to delay in notification, and also it may overwhelm the receiver. So he might feel like he is getting too many notifications, but in fact he has registered for only one event. So to avoid that, we are also doing a duplicate detection of subscribers. And then we are also trying to minimize the database queries, so for every event happening, we don't want to go to database and fetch the data. And large volume handling is something which is needed, because we want to handle a large volume of notifications as quickly as possible. And also we have notification prioritization. So there are certain notifications which need to be prioritized compared to others. So let us see how these principles are realized. So we are using MongoDB indexing so that, and also some transformation and cleaning of the data so that the data is stored in an optimal way. And pre-check on endpoint is something like we do certain checks like get request and so on. And we also check the authentication parameters if they are proper so that we only store the subscriber data which is correct. Of course, in future, maybe this endpoint may be invalid, but at least during the registration phase, we ensure that the notification endpoints are proper. And also, we are doing the duplicate detection of subscribers so that we don't have any duplicates in our system. And to minimize the database access, we have a plan to use an LRU cache, which can be in per NBA or to use a system like a Redis. And to handle large volume of notifications, we have done something which I will be discussing in later slides. It is related to Kafka and NBI. And notification prioritization is something like, say if I notify to the endpoint, and if the endpoint fails or the receiver doesn't acknowledge with the proper status codes, and then we drop the notification and we shall retry for it after a certain period of time. So this is how we achieve notification prioritization. So next is the high level flow. So this is so before I go into the flow of subscription and notification, I just want to give a quick walkthrough of the components of OSM. So this is an architecture diagram which is taken from OSM white paper. So we can see on the left side that we have all the common services, databases, and TSDBs. On the right hand side, we have the Kafka bus, and on the top we have all the OSM clients, which is ITY, NGY, and OSM CLI. And these clients will be able to send requests, HTTP requests to NBI to interact with OSM. So this is how it works. And what we can see here is the LCM, VCA, RO, POL, and MON. They are all produced. They are all. We can think of them like they are all producers to Kafka, and NBI is a consumer to Kafka. So all the events of the life cycle of the network service will be present in Kafka. So Kafka acts as a data source for our notifications. So all the data is present in Kafka. So whenever anything happens to the network service, LCM or one of the modules will produce it to Kafka. And so NBI will be able to pick it up. So this is how it works. And there is a consumer in NBI, which is having a consumer ID of NBI-server. So it will be able to receive all the notifications, not notifications, all the events happening in the OSM system. So once he receives the events, he'll be able to he will be able to see if this event is necessary or not. So that kind of logic is written inside NBI. So NBI will be acting as the subscriber, in the sense he'll be able to receive the subscriptions, and also he'll be the one who will notify to the external systems like OSS and BSS systems. So this is the like in-depth steps, what happens exactly during this subscription. So subscriber's input is validated against the JSON schema. So the NBI validates it. Then we do the endpoint check. Is that NBI correct or is it up or not? And we also check the authentication parameter. We also do the duplicate detection. Duplicate detection of is very complicated. I just have an example JSON body of how a subscription request will look like. So on the left hand side, you will be able to see a simple subscription data. So what we have on the leftmost side is a filter, a callback URI, and the authentication. So we can have, so the authentication we have type as basic for, and there can be no authentication type. So in that case, this block will be empty. I'm not sure if you are able to see the. Can you just say me which slide you are seeing?
Currently, it is visible for high-level flow subscription steps, that JSON body shy.
Yeah, okay. Thanks a lot, Bharat. So on the left-hand side, we'll be able to see the filters, and we have a callback URI, and we have authentication details. So in case if authentication is none, then this block will be empty, And in the filter section, here is where I was saying, like, we can have a lot of configurations done here. Like, we can specify a wide variety of combinations through which the subscriber can select the event in which he is interested in. So we can see like, so NS instance subscription filter, in that there is a key like NS IDs. And so this is one of the parameters which is specified in source and which is present in this example. There can be many other identifiers to which you can refer. For now, we are saying like this ID. So for this ID, it can have an instantiate or terminate as operation type, and operation state processing completed or failed. If any among these things happen for this network service descriptor, then an event should be raised to this callback URI. So basically, this is what this data model shows. Of course, there are a lot more keys which are supported by each of these types. However, I have just showed the basic one. Uh, so, and then the fourth step is going to be the data reformatting. So moving along to the notification steps. So, so when event occurs, so as I said, the Kafka is going to be the data source for all events. So a Kafka consumer will be running in NBI, and he will be getting the event, and we will process the event and see if there is any subscriber who is interested for this event. If there is no one interested, we will drop the message. And if there is someone who is interested for that event, and we will prepare a payload for that receiver, and then we will do an asynchronous HTTP post to send the notification to all the receivers. So in case if the endpoint fails or if that endpoint is not working, we will retry it for 5 times with a backup delay, which is increasing exponentially. So say for first time it fails, so we will have a backup delay of 2 seconds. If the second time fails, we will have a backup of 4 seconds. So it will exponentially grow till 32 seconds. And even then, if the receiver doesn't acknowledge, then we will drop the notification. So that is what we are doing. So we don't know for as of now we are dropping. Maybe in future we will store it in database or something. So this is basically the current support in OSM. So whatever I have described so far, the JSON schema validation, pre-check of endpoint, duplicate detection, and data formatting, it is present in OSM. And for notification, optimal query is there, and SOAR compliant response structures. So if you see in the if you see that JSON body, we have something called as notification types. So there are multiple notification types for which a subscriber can register himself. So for now, in this example, it is LCM, operation occurrence notification. So similarly, there are some things like creation notification, deletion notification, and chain notification. So for each of these notification types, we have separate payloads. So based on the notification type, we generate the payload. So that is also something which is taken care of in this release, and the backup period is also being done. So in future release and roadmap, what we have is to support the same set of functionalities for network service descriptor and VNFDs, and also for now the authentication mechanisms are OAuth and TLS, and we have planned to support these two in future. And for now we don't have so it supports currently for no authentication and basic authentication, and the cache is something we are trying to bring in via Redis. And also we are trying to improve some messages in Kafka. So all the keywords what we saw in the JSON body, so they are all, not all being produced in Kafka. So that is what we are trying to improve from Kafka side. So with this in place, we will be having a full-fledged subscription and notification feature. And to conclude, by subscribing to dynamic changes in the network, operators can assure real-time continuity of their services, and subscription mechanism is completely configurable as we have seen in the filter section. So users can choose a wide variety of combinations for the events which we are interested in. So they can choose NSDs, NSD ID when a network service is not yet deployed. Say suppose network service is already deployed, they can choose NS instance ID to get the notifications, so something like that. So there are multiple parameters available through which they can choose. And also subscription and notification feature is a key enabler for end-to-end service assurance. So that is all from my side. And I would like to give special thanks to Alfonso for supporting me throughout the development of this feature.
Okay, thank you. Thank you to you for developing it. It's a great work.
Thanks a lot, Alfonso.
So I haven't seen any questions yet in the chat, but if anyone would like to ask any questions, feel free to do so in the chat window, or open up your mic and speak up, ask your question in person.
Hi, Sai. Are these filters and the notification things, callback URLs, part of OSM release 8?
Yeah, Shweta, they are supported as of OSM release 8.
Okay.
So the payload, what we are seeing is something which is designed in Soulfire documentation, and we are supporting the same structure in OSM release 8.
Okay. One more thing, where can we find these filter configurations after the installation?
So one thing I would recommend share that is to go through the document in the chat. And the other thing is like I believe there is an through which you could all the document to find documentation also for this. Like what are all the
Your voice is breaking
parameters
for
available,
me. I'm not sure for others.
and UIs are
Sai, your
integrated
voice
here.
is not audible, Sai.
Be able to subscribe and receive notice, but APIs you should have notifications.
Sai?
So am I audible now?
Previously we don't hear
Hello?
anything from your side.
Am I audible now?
Yeah, now it is fine.
Okay, sure. I'll just okay, thanks a lot. So what I was saying is like all the data model what we are seeing, this is something which is designed in the Soulfire documentation. So we are saying that respect to the usage point, if you want to find how do we interact as with respect and how these things, maybe you can do it using NBI APIs, or there is also available. I believe there is an open API documentation.
Okay, can you please write
Hello,
in the
is my
Slack,
voice audible?
because no, it is not. So can you please answer in the Slack? That's fine. I will have a look in the documentation.
Yeah, sure. I'll just share all the links in the Slack. Yeah.
Yes, unfortunately, we seem to have troubles with your audio connection right now, that it's not clear that what you're saying. So we see it in the chat. Thank you for confirming that. Actually, are you able to switch over to the Slack channel for Hackfest to post those so that we have a record of it after the presentation ends?
Maybe I'll just share it after the presentation ends. Is it okay?
Sure. Yes, anytime.